Good morning, everybody. Hello, how are you doing? Can you believe it's already the last week in this block? Yeah. You can? Okay. Yeah, I know it's been a tough block for you. Okay, in the previous lecture, we discussed the pandas package, which we use to manipulate objects that store tabular data for us. We've learned about the series data type, the data frame data type. We learned that series could have names. Data frames can have columns and rows and labels associated with columns and rows. And we also learned about a number of elementary operations on these data types, and in general how pandas handles data. In this lecture, we will talk more about the useful methods that are provided by the pandas package for us, and we will also discuss a number of important subjects, for example, how to manipulate the shape of a data frame, how to merge different data frames together, concatenate them, and a lot of other important stuff that we will use throughout our data science projects. Okay, so without further ado, let's get started. All right, so I'm going to begin by showing you a couple of just useful functions, and I'm going to go a bit quickly through them. It's just to show you how you can explore your data set once you have loaded it. Here I have a data frame that stores information about movies called data.imdb.csv. We load it, and it's basically each row shows the information about movies, release year, the title, the runtime, and so on. Okay, so let's see how I can see 10 rows of the top of this data frame. So df.head, and then within the parentheses, I can specify how many rows I want to see. And yeah, so here we go, 10 rows. df.tail does the same thing. If you don't provide an argument to it, by default, it shows you 5 rows. So head of the data frame, tail of the data frame. And also, if you want to quickly see what is the shape of your data frame, how many rows, how many columns, just like NumPy, you can do df.shape, and it's, yeah, again, similar to NumPy. A very useful method that I use a lot myself is df.info. So when you run that, you see a summary of what's going on in the data frame. You see the column names, how many non-null values you have, the data types for each column, and also the memory usage at the bottom of the output here, which can be useful when you're working with large data sets. Again, these are just convenience functions to just quickly see what's going on in the data frame. df.describe. This gives you a statistical description of the numerical columns in your data frame. For example, you can see the count, the mean, the standard deviation, the quartiles and the maximum values and things like that. And again, it's useful for numerical columns if you just run that method like that. But if you have, for example, categorical columns as well as numerical data, you can also supply this parameter, include all, and then this will return to you not only the information about the numerical columns, but also about the columns that contain other types of data. Obviously, this might not make much sense for a lot of the columns, but sometimes this could be helpful. For example, here in this unique row, you can see that we have 999 unique items in the series title. It means that, so if this data frame contains 1,000 rows, it means that there are there's one duplicate value. You can also see that what is the top item occurring in the data frame based on the frequency and what's the frequency of that item. So you can already see that this is relevant mostly for categorical data as well as for string columns. Okay, and finally, there's this df.dtypes, which contains information that we already know how to retrieve using the df.info. But again, this may be something that could be helpful to quickly check the data types for all of the columns. Now I'm going to show you the options for how data frames are displayed on the screen for you. So by default, if a data frame has more than 60 rows, Pandas will only show you the first 5 rows and the last 5 rows. This is something that you can change yourself. So here, if I have more than 60 rows, this is how it's shown on the screen. If I have fewer than 60 rows, you can see that all of the rows will be printed. Again, this is an option that you can modify. So pd.set option. It's not a very important thing, but it's something that's nice to know. PD set option, you say that set the maximum rows to display to 20. So as soon as the number of rows exceeds 20, it will again show you 5 rows at the top and 5 rows at the bottom of the data frame. Yes?
Is there an option to change the amount of rows that it will show? Like instead of 5 on 5?
Yeah, I think so. Yeah. There's certainly an option for doing that. And also there are other options for specifying how many columns you want to see and stuff like that. So this is just to show you that this particular option exists and you can explore it further in the documentation. Okay. And again, something just so you know, these things exist. You can also color the values inside of a data frame by using this style attribute for your data frame object. For example, here, that's random values inside of my data frame, 10 by 10. And you can see that I've provided a color map, and then according to the values, different colors are associated with different elements inside of the data frame. This again can have its particular applications in some cases. Okay. So just to recap, this is just a pointer to you that you can go and look inside the documentation to see the kind of functionalities available to you with data frames before you get started and write your own functions and your own code in order to produce the same thing after a couple of hours. So this is already available. Okay, before moving on to the next part, any questions about this part? So again, just a bunch of convenience functions to see a summary of what's going on. Okay. Well, you remember that we have talked quite a bit about when Python, for example, takes a copy of objects or returns just a view of the objects or returns just a reference of the objects. And here I'm going to talk about this in the context of data frames in Pandas. So suppose that we have this row inside of our movie data frame, and in the released year column, we have that incorrect value. The correct value is 2010. However, here it's 3010, and we want to fix that particular entry. Okay, so you might do something like this. df, and here I'm retrieving the item, okay? And then here, I'm going to grab that particular column, that particular column of that returned series, and then set it to 2010. Okay, so let's see what it does. As soon as we do that, we get this warning here. It says setting with copy warning. And this is something that you probably are going to see in a couple of occasions until you get used to what it is and what it means. So what it means is that Pandas, instead of setting that value 2010 inside the original data frame, it actually sets that value on a copy of the data frame. So let's see why that happens. Okay, I have done this just to prove to you that this value didn't change inside the original data frame. Let's take a look. It's still 3010. Okay, so we didn't achieve what we wanted to do. And just as a quick check, and for you to make sure that these two objects are actually different, let's check the memory ID of the data frame, the original data frame, and also the memory ID of this particular subset of that data frame. Okay, so if I run this, you can see that the IDs are different, meaning that when we do this over here, this particular data frame, this object, is not the same as the original one. So it's trying to grab this released column and set it to 2010 on a different object. And this is the proof that a copy is taken instead of modifying the original object. Okay, so whenever we want to set values inside of a data frame by using those slices that I've taken here, we will take a copy inside of pandas. So whenever I try to do something like this and then look into that particular subset and set it to a value, pandas will take a copy. If I want to avoid doing that, again, just like I mentioned in the previous session, always use lock, .lock or .ilock. So here, I'm doing everything in one go. As you can see, I'm not first subsetting the data frame and then subset it again in order to set that value. I'm doing everything in one go using the .lock function. And now if I go ahead and do this, let's check the original data frame, and I can no longer see that row which shows a value greater than 2021, which is proof that that value has changed. And let's see if that's true. Yes, we can see 2010 over here. Okay, let's go back, have a quick recap. So what was the difference? The difference is that here, again, whenever I do something like this, I will take a copy. So Pandas does not know how to work with these chained indexing kind of thing that goes on the left-hand side. So first, when you work like this, it has to take a copy of the first bit, and then as soon as it has that in the memory, then it can index further into that data frame to grab the released year column and then set the value, which is why Pandas takes a copy first and then does that. However, when you do that, so this is a two-step operation actually. So whenever you're doing this, you should be very careful because although Pandas will show you a warning, in some cases it doesn't. But in case you're getting a warning, this is what happens. The value is being set on a copy of the data frame, not on itself. So questions about this? Yes?
Within the first square brackets, the value of, the result of the equation, in the equation is array of bullets?
Yes, exactly. So this first bracket over here, so I could actually write it more nicely for readability purposes. I can do mask and then provide mask here just to make it more readable. So at the top I have a Boolean mask which just returns trues and false inside of a series. Okay, then I pass the mask to my original data frame. As soon as I do that, Pandas takes a copy. And then it sets the value on the copy, which is not what we want usually. Okay. All right. By the way, I have made a number of edits to the lecture notes on the course repo. So if you happen to have cloned that repo on your own machine, just do a git pull to pull the latest updates on your machine. Okay, any other questions about this setting with copy warning? Okay, so, yeah, sure.
Actually, even if you don't try to change the release year, at the moment when you apply the mask, the copy happens.
Yes.
Okay.
Yes. Yeah. Yeah. Yes.
So now that the copy is made, when does it get deleted? For example, for memory purposes, where we're working with big data sets,
Yeah.
a lot of memory, do we have to delete it by ourselves?
No. Okay, that's a great question. So in Pandas, in Python in general, we have a mechanism called garbage collection. So whenever there is a chunk of memory allocated to some particular data, if that particular data does not have a reference, a valid reference inside of the Python runtime, then Python periodically automatically deletes that data for you. So it does garbage collection for you. In some other more lower level programming languages, you have to reclaim the memory yourself. It's not automatically done. But Pandas does that for you. So as soon as you lose the reference to that data, for example, you overwrite df with something else, then that df in memory becomes orphaned, and then it will be garbage collected. Yeah. Okay, any other questions? So always use .loc and .iloc if you can. Okay, let's move on. Now let's take a look at some basic data frame manipulation methods. So let's see, for example, we have the data frame over here, and suppose that we want to rename some of the columns that we have, some basic data wrangling techniques. I might not be happy with the column names that I have here. I want to rename them. So we have learned in the previous lecture that I can access the column names and indexes or the row labels by typing df.columns and df.index. That gives back to us the labels that we have, so I can modify them directly. I will show you that. But before that, there is a method called .rename, and I can provide the existing column names as a key and the ones that I want the columns to be changed to as values inside of a dictionary. For example, here I'm changing released year to year and *1 to actor 1. So let's see. We have released year over here and *1. I want to change those two names to year and actor 1. Okay, so it didn't happen. Why not? Because this is not an in-place operation. Usually, most of the pandas methods are not by default in-place operations. So there is usually an option called in-place, which you can set to true yourself, that will make the changes in place right in the data frame, in the original data frame. But usually, by default, pandas operations return a copy to you, just to be on the safe side. But this is something that you can modify. Okay, so here I'm changing these column names. However, I'm not modifying the data frame itself. This is why the original data frame is not changed. And we had a question similar to this one in lab 2, which I wanted you to actually implement this in-place argument for your vector objects, so that you had the option to modify things in place or return a copy of your vectors. Okay, so in order to make the changes happen inside the data frame itself, you have to reassign it to data frame like this. And again, related to your question, when we do this, the original reference to df will be destroyed, so that original copy will be destroyed, and this new copy will be assigned to df. Okay. Now, if I do this, I can see that this is changed to year, and *1 has been changed to actor 1. And this is just another example of how you can rename the columns by directly modifying this df.columns attribute. Here, using list comprehension, I'm producing this particular string over here, okay, which is just as column 1, column 2, column 3, starting from 0, of course. And I can do something like this. You can see that all of the columns have been renamed. This is also something possible. You can directly modify df.columns, df.index. Okay, questions? All right. Okay, so now what we discussed was about column headers or column labels. Something quite similar can happen to the index of the data frame. For example, if we look at the data frame that we have, we can suppose that we want to change the index column over here. For example, I want to use my first column over here as the index instead of, the column 1, which represents the year, the production year of that movie, as the index instead of this range index that I have on the left-hand side, okay? I can do that using this setIndex method. SetIndex, and inside the open close parentheses, I supply the column name, the label of that column. Okay, let me do that, comment this out for now. You can see that column 1 has been moved to the left-hand side, and now that is the index of my data frame. Basically, that is the label of my data frame. And what what can be done with this is that now we can use the .lock function in order to retrieve items based on the production year, because now this is the index of the data frame, so it's labels for our rows. And if you want to make it really similar to what we had before, you can actually, if you want to give a different name instead of column 1, if you want to set a different name, what happens? Okay, yeah. If you want to set a different name, you can do df.index.name and set it to a different name, and then, okay. Yeah, so let me just reload the data real quick here. Sorry, I have to scroll back up, load this. Okay, sorry about that. I commented that line out, and then now it doesn't work without that. There we go. And now let me run that. Sorry about the scrolling. Let me do this again. Okay, here we go. This is what we have, and now if I do this, you can see that I have renamed the index to new index, or more relevantly, I can rename this to year or production year, something like that. Okay, and sometimes I want to send back the column that's denoted as index, and again set the index to the default range index that I usually have. What I can do is I can use the reset_index over here, and what it does, it sends that index column back to the original data frame, sets it as a separate column inside the data frame, and then sets the index to be the default range index on the left-hand side. This is useful because some of the pandas methods modify the indexes, and most of the time you want to reset the index and go back to the default values, and then do something else with that index column. I'll show you an example of this as we move on through the lecture. Okay, so reset index, set index, these methods will help us to pick a column and set that as the index, or reset that index column, send it back to the original data frame, and then use the default range index. Okay. Once again, we have direct access to df.index, so if we want, we can directly modify that row indices. So here I'm setting df.index to this object, which is basically just a range object like Python for loops. And here I'm setting the indexes to start from 5,000 and go all the way up to 6,000. Okay, so the point is I can directly modify df.index or df.columns. Yes?
Is there a benefit to one way over the other, like with rename instead of .columns?
Okay, so if you do, so rename is for changing the label of the index, but for the values, you might want to use one of the columns to be your index. In that case, it's helpful to just use set index and pick that column instead of manually going and grabbing that column and setting that to index. But otherwise, no. Other questions? Yes?
She was actually asking for the difference between .rename and .column.
Oh, dot rename and dot columns? Was that the question? Okay. Okay, let's go back up. Sure. Again, that's the same thing, basically. Oh, no. So again, rename is about the name that you assign to that particular index. So you have the row labels. You can assign a name to that row headers. So the collection of the row headers, the collection of the column headers, you can assign a name to that. The collection of the row indexes, you can assign a name to that. So df, sorry, I have to correct myself. Okay. Yeah, rename is for renaming the headers, not the entire name of the, yeah. Sorry about that. I get that mixed up. Yeah, that feature is, you can grab that name feature by using this df.indexName or df.columnName. Sorry, that sets the name for the entire column labels, the entire row labels. However, for setting the individual indexes, we can use that rename, which changes, you can change a column header or a row label in place, just individually, or you can assign a collection of them to the index object or to the column object directly. So again, if you, most of the time, using these functions, these methods, is for readability. So you might be able to do something in different ways, but usually the way that Pandas recommends, for example, df.rename, makes the whole code much more readable if somebody else sees that. Instead of grabbing like an element inside a list and then setting it to something else, you say the df.rename, and as soon as I, as another person, another coder, see your code, I say, okay, yeah, that's renaming stuff. Okay. All right. Okay, now let's move on to how we can add or remove columns. So adding a column is actually very easy, adding a new column. Here we have the original data frame. And then what you can do, if you want a new column called, for example, Rotten Tomato score, which is a website for rating movies, suppose that I also want to store those movie ratings alongside IMDb rating in the data frame, I can directly index into that, and by that, when Pandas sees that particular column doesn't exist, it creates that for you. Very similar to what we have with dictionaries. Whenever we refer to a key inside of a dictionary and we want to do some sort of assignment on that, if the key exists, it will be updated. If it doesn't exist, it will be created. And the same is true about Pandas data frames. And here, a new column is created, Rotten Tomatoes score, and all of the values are set to 0. So very convenient way to quickly create a new column and fill it with values. Okay, now removing columns, I can use this method called drop. So df.drop, and then specify the name or the header or the label of the columns that you want to remove, and then it will do just that. So I remove the certificate, the meta score *3 and *4. So you can see that only *1 and *2 remain in the data frame. And notice that I'm always reassigning the results of those operations back to the original data frame because these operations are by default not done in place. Okay, now about adding and removing rows instead of columns. There is a deprecated method called .append, similar to lists, but this is something that's going to be removed from future versions of Pandas. I will tell you how you can add rows to Pandas data frames by basically concatenating two data frames together instead of appending something to the data frame. But that will come up in the next sections. However, for dropping particular rows at specified indexes, we can again use the drop method, and then here specify the indexes of the rows that we want to remove. So here I'm indexing into this index object itself, and I'm telling the code to remove everything from row 5 up to all the way to the end. So here you can see that only 5 rows remain in the data frame. That's because I have dropped anything beyond row 5. And notice this axis parameter here. So axis 0 means that I want to do operations along the rows, along the row direction. Okay, not along the rows, along the row direction. What is the row direction? The direction that the index of the row increases or decreases. That's the direction of the rows. What is the column direction? That's the direction in which the index of the columns increases or decreases. Okay, so axis 0 is the first dimension, the row direction, and this is why I'm removing things from this side. and axis 1 will be the column direction. So we will remove things from the columns. Okay, one other indirect way of removing rows is basically by just taking slices or subsets of our original data frame. Here I'm subsetting my original data frame by using these slices, everything up to the third row and everything up to the fourth column, and that gives me a subset, that gives back to me a subset of the data frame. Okay. Any questions about adding, removing rows, adding, removing columns? Yes?
Is the dot index by index name or position? Like if your index was dates, you wouldn't do find on, you would do date to date.
Oh, yeah. So if you index into that object, that will be by index position, but you can grab the labels using the square brackets as far as I remember. So it's definitely not just by index position. You can also use the labels in order to do that. But we usually, in this case, we usually don't do that because we can grab the indexes themselves inside of a data frame by just directly referring to them using the labels. Yeah. Any other questions? Yes.
Yes, another really useful log. Those are done in the original data frame. If we do it like that, for example, slicing the original data frame, we lose all the data, so we cannot go back.
Okay, good question. So when we use iloc, like this over here, do we lose the original data frame? So in this case, because I'm assigning the result to a different data frame, no, df will still remain the same. It's not in place. But if I reassign it back to df, obviously that'll be overwritten, and I'll lose the original df. So. Any other questions? Okay, let's take a break for 5 minutes and then move on with the rest of the lecture. Okay, let's move on. So, in this next section, I will talk about how we can reshape data frames in order to be able to do some certain operations that might not be possible with the shape that we currently have. So, I've asked you in the last lecture whether you have learned about the concept of tidy data, and you said yes. I think you've learned about this in 523. So, you know that in tidy data, we're supposed to have each observation on a separate row inside of our table, and also each variable should be in a separate column. So again, just as you can see on this diagram, each observation on a single row, each variable inside a single column, and then each single element represents a value for one of the variables. Okay. However, sometimes this might not be the right format when we want to process the data. Suppose that, for example, when we do plotting, and you will learn about this in detail in the next blocks when you learn about how to visualize data, it's sometimes more convenient if instead of, for example, here, I have team ABC and I have different measurements associated with these teams. Instead of this, it would be great if I can have A associated with this 88 number, and then A with 12, and then A with 22, something like this, so that I can basically categorize the data. So if I show my data on a plot, I can directly pass this data frame to it and say that, hey, the column team shows the category of the data, some category or some label. So usually the plotting packages understand this very quickly and then represent your lines on a plot with different colors, for example. Or sometimes it might be easier to process this kind of data by saying that, hey, collect all of the rows that have value A in the first column and then do some kind of operation or manipulation on them. And we will learn about this particular type of operation. It's called group by. So for these kinds of processing reasons, we might want to convert our table from this format to this format. Can you also point to one other advantage that we get by using that format on the right-hand side compared to the left-hand side? There is one important advantage, and it has to do with storage somehow. Yes? Okay. 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 Yeah. Bad timing. Okay. So one thing is that if I store my data like that, if I have a new variable, I don't need to modify the entire table. In this case, if I have a new variable on the right-hand side of the table, another quantity, another variable, I have to assign that particular number to one of the rows, and maybe I don't have values for all other rows. It's just that row that has that particular variable. So in that case, I have to repeat a lot of null values for all of the rows, and yeah, and I have to modify the table itself. In this format, I don't have to do that. Just add A, and then a new variable, and then its value. So that's another advantage. What is a disadvantage of using this? So we don't have to modify the table if we have new data, but yeah, there's a trade-off. Yes?
If I want to find the mean points, it's a little bit harder to do it
Sure.
in the long format.
Yeah, that's right. That's right. It's not as straightforward as it is with this format. What else? Again, it's something about storage. That's what I'm looking for. So we learned an advantage is about that we can add new variables. What is a disadvantage with this format? Storage. There's something going on with the storage. Yes? Exactly. Yeah, good point. We have a lot more rows. We have a lot of repetition. You have to store all of those A's and B's and points and assists and rebound. And when you have a table that's a terabyte stores a terabyte of data like that, then it will be a lot larger if you do that on the right-hand side. So there are advantages and disadvantages with these formats, and it depends on what you do. We'll learn about the implications of these in our database course 513 coming up in block 3. Okay, so this format is called the wide format, meaning the standard way of looking at data, observations, variables, and this is called the long format because we repeat everything and we have usually the variable column and the values. Now, I want to tell you how we can convert between these types in pandas. So there are functions, methods for doing these conversions. The first one is melt, which is for converting wide data to long, and then pivot, which is for doing the opposite, converting long data to wide. And then I will discuss another method called pivot table, but for now just disregard that. So melt and pivot. Let me show you an example here. Suppose that I have a data frame like this, instructor names, and then the number of courses they teach in each year, or they have taught. Okay, so if I do df.melt, look what happens. So pandas has taken each one of the column headers, has taken it to be a variable. So name is a variable, 2018 is a variable, 2019 is a variable, and so on. And it has provided me with all of the pairs that are imaginable with this data. So name and Armand, name and Mike, name and Tiffany, name Verda, name Joel, and then going to the next column, 2018 with 1, 2018 with 3, 2018 with 4. So it still contains the same data, but the format or the representation is different. Okay, so if you do .melt, it just melts all of the columns into a long format. Takes the column header, it takes it to be a variable, and then gives you all the possible pairs between the column header and the values. Okay. However, in this particular example, I might not want to melt all of the columns. So in our previous example here, I didn't really want to melt the first column. I didn't want to have team and the value A, team and the value B. That doesn't make any sense in this context. So suppose that I want to keep the first column, melt the rest. So in order to do that, which is something that we usually do, we have to provide this parameter, ID variables, and that means that we have an identifier column, which tells us what this row represents. What is this observation? And pandas will keep that intact for you. So if I specify that I want to keep the column name, and look at the column name over here, I want to keep this one, melt everything else. And now it looks a lot more like what I might have intended to do. Okay, so it has kept the column name, and it has repeated it as necessary, but it has melted all of the other columns. So again, for all of the other columns, 2018, 19, 20, I have all of the pairs between the column header and the values stored in them. Any questions about this melt ID vars? Yes?
Can ID vars have more than one element?
Yes, good question. Can ID vars have more than one column header in that? Yes, absolutely. And when you do that, it will give you multiple indexes, which I will get to in a bit, but this is not something that we really explore that much in this course. Okay. So, now one thing that we can do, there are other arguments with this melt. So ID vars, we learn about this. This is the column we want to keep, melt everything else. And now there is this value vars here, value variables, which, by which we can tell pandas which one of the columns we want to keep in the melted data frame. So here I say, okay, I don't care about 2018 or 2019, just give me the column 2020 as the variable and associated values. Okay? And notice that here we have a list. I can specify, for example, 2018 and 2020, and then it will give me only 2018 and 2020. Okay, and just doesn't include 2019. Let's go back. Okay. Yeah, so here is that example coming up. And we can also, instead of having this variable and value column headers, which are the default strings, default labels for the columns, we can also have different names for them. So for example, I can name this variable column to something that's more meaningful. So I've named this column year because that's what it means in this case. And we can also name the column value to be something else. So in this case, it's number of courses. So I'm going to have something like this: year, number of courses. This is still the variables, and this is still the values. I've just named it differently. Okay, so before moving on to pivot, any questions? Okay. Just to recap, this is the column we want to keep as it is. We don't want to melt it. This is the name we choose for the variable column. This is the name we choose for the value column. Okay, this is about melting, converting wide to long. Now, how we can go in the other direction. We use this method called pivot. This does the opposite. So with pivot, we specify an index column, okay, and then we specify that index column represents the column that we didn't want to change, like the name column. And then in columns parameter here, we specify which one of the columns inside of this long table I want to pick and extract the unique values out of it and then put it as separate columns in my pivoted table. So here, I'm saying that index is named, that's the one that I want to keep, and then look into the columns, look into the column year, pick every unique value of year, and then assign a new column for that in the new table. And you also specify which column represents the values for those. So it does exactly the reverse, okay? We're telling it pick values, pick unique values from this year column, create new columns for each one of those unique values, and then use this to fill the values for those columns. Okay. And you can see that when I do the pivot table, I'll get names for my column headers and also the row indexes. So here by default, it will assign this column name year to this column labels, and then assigns this name to the row indexes, which just takes from these values that I have supplied here. If you want to remove those, so you can see that the columns is represented by this index object. It has a name associated with it, and here I can basically look at this attribute columns.name and set it to none, and then reset the index using what we've learned, and then we'll get back the original table that we had. So we removed the column name, and then the index was different. Notice that the index was set to be this index column, okay? And I reset that, so I sent it back as one of the original columns in the table, and now this looks exactly like what we had in the beginning. Okay? So one operation, wide to long, and then long to wide. Okay. So there is this other method called pivot table. I don't go too much into the details of it. I'll just want to show you why there could be a problem with this converting from long to wide. For example, here, if I melt this table that I have, suppose that it's something like this: instructors, departments, years, and number of courses. Okay. And now, if I try to go back from this to the original table at the top, so extract the years and put them at separate columns, we might run into a problem, because if I want to do that, for each name combination of name and year, we might not have one single value. Okay, so here for Arman in 2018, we have two values. So when I want to construct my new table, what is the value that I should use? Because now there's two. So pivot table is used for these situations to remove the ambiguity. One thing that we can do with it is to apply an aggregation function, meaning that, hey, as many numbers as I have, just sum them up, or take the average, take the minimum, take the maximum, convert it to a single value, and then do the conversion from long to wide. Okay? So this pivot table, this is the only thing it does. Okay? The only difference is that it deals with situations when we have multiple values for a combination of an index and a column value. And let me just run this to show you how this happens. Now, because the ambiguity is removed, we don't get an error. In this case, we will get an error because it's ambiguous. And here we don't get an error. And if you really want to keep everything, we have to have a way to represent multiple values for each of those combinations. You can do that, but you will get multiple indexes like that. You can see that Arman and the year are represented by two values instead of just one. And here you have two indexes instead of just one. Again, we don't go into the details of this. This won't be on the quiz or anything. It's just for you to know why this exists. Okay, so before going into the next section, any questions about melting, pivoting, long, and wide? Yes? If there's a blank row. Mm-hmm. Yeah. If there's no year. Okay, let's go back to. Okay, so in this case, if like the year column exists but it's empty, or I suppose you'll get an error. I've never tried that, but yeah, I think you'll get an error. Yeah. Any other questions? Okay. Okay, so did you have this, have you covered this topic in 523? Okay, so because this is something that could be a little confusing in the beginning, and I don't see anyone struggling with this, which is a very good thing, because this was confusing to me when I was first introduced to melting and pivoting, but yeah, that's great that you already seen this. Okay, so now let's talk about how we can combine different data frames together by just simply concatenating them or joining them together. We'll learn what these keywords basically mean. So let's suppose that we have these two data frames over here. Okay, very simple. A, B, some values, and the row indexes are the same. And there is this method inside of pandas called concat. And if I run this, it does exactly what I want it to do. So here, inside of open close parentheses, I supply the name of the data frames that I want to concatenate or join together. Not join, actually, but just concatenate. And then specify the axis along which I want this operation to be done. So here, you can see that we had A and B, 1, 2, 3, 4, 7, 8, 9, 10, 1, 2, 3, 4, 7, 8, 9, 10. And you can see that the index actually is repeated for the second data frame, 0, 1, 2, 0, 1, 2. Okay? So we've concatenated them along the row axis. And you can also add multiple data frames, not just two. You're not limited to two. Okay, so there is an argument. If you don't want this to happen, this repeated indexes, you can add this ignore index, set it to true, and then that basically resets the index for you. All right, now we can do the same thing along the column axis and ignore index, and here is what happens. Okay, so now the concatenation happened along the column axis. And again, we're not limited to just two. We can do this as many times as we like. So we can copy things over and over and concatenate them together as we like. Okay. Now let's move on to merge. I think, again, this is something that you have seen in 523. Okay. So this will be quick, I guess. So the concept of merging comes up, again, in our database course a lot because efficient storage of data usually results in splitting tables. Instead of storing everything in one place, we split data across various tables to avoid repetition. And that implies that we have to join those tables back together whenever we need to. And this merging inside of Pandas does exactly that for us. Let's see how it works. So since you're already familiar with that, I'm just going to go not in too much into the details of it, but suppose that we have this df1, df2. So yeah, basically just name, alignment, gender, publisher, and columns like that. And in this case here, we only have the publisher and year. So you can see that we have this common column between these two data frames, and this is uncommon between the two, and these three columns are also uncommon between the two. Okay. This is just these two data frames created inside of Pandas. And now, let's see what happens if I do pd.merge. So pd.merge accepts two data frames, one data frame on the left, one data frame on the right, and then you tell Pandas how you want to join those two tables together. So we have inner joins, outer joins, and I'll show you what those means, and the column that you want this operation to be done based on that. So here, I'm saying that merge df1 and df2 based on the column publisher and do an inner join. What it means is that Pandas will look at the publisher column, and then whenever it sees common values, it assigns the values that I see on the right to the values that I see on the left. So for example, here, the value Marvel is common between the two tables. Okay? So it looks at that, okay, and then here we see year 1939 because that was common. We see 1939 repeated here for every row that contains Marvel. Okay, so Marvel here is associated with year 1939, and this is what we see over here. DC, again, is something that is common between the two tables. So here, for every value of DC that we see, the value 1934 will be assigned to that. And the publisher image here is not common. Publisher dark horse is not common, so we don't see those values in the resulting table. This is the concept of an inner join or inner merge, meaning that we only take the common items and we discard the items that are not common. And if we do this join, you can see this is what results. Only the common items, Marvel and DC, are common in the publisher column between the two data frames. An outer join is kind of the opposite of that. It not only returns the common values, but it also returns everything else. And when we don't have a value for that, it just fills the columns up with unknown values, so not a number, NaN. Dark horse existed in publisher in the left table, but didn't exist in the right table, and image existed in the right table, not on the left table, so we can see NaNs for those values that don't exist. Okay, left keeps everything in the left table and only the common things on the right table. This is what you see here. So image is on the right table, so it's not going to be kept. But dark horse is on the left table, and this is a left join, so we keep everything here. This is why we see it in the resulting table as well. And right is the opposite of that, with the difference that it returns to you everything in the right table. Okay, there is this argument here, this parameter that we can add to our merge function, which shows which items have which one of the tables the items have been taken from. So it says that this dark horse had been taken from the left table only, and this image one has been taken from the right table only. Okay, any question about this merging and joining operation? Again, this is something that could be tricky if this is the first time that you see it. But fortunately, you have seen this in 523 already, so I hope it's not too confusing for you. Questions? Okay, let's move on. So, what happens if I want to apply a function to all of the values inside of my data frame? There are two convenience functions provided to us by pandas. One is df.apply and the other one is df.applyMap. Let's see the difference of these. So suppose that we have the YVR weather data like this in a data frame, and suppose that for some reason we want to take the log of the mean max temperature column. The way we can do this is that we index into that column, or those two columns, month and mean max temperature. I don't know why I should be taking the log of month, but just for the sake of this example. And then apply np log, and it takes the log of those values for us. So apply, the .apply method, receives a function or can work with a function that works on a series of data or vectors of data. Okay, so here, pandas returns those two columns to np.log, and np.log knows how to work with vectors or with series. Now, suppose that I have a custom function over here which converts those temperatures to degrees Fahrenheit. I can define that function myself and then use .apply to apply that onto those two columns. It works pretty much in the same way. And then I can also use an anonymous function. Instead of defining something using DEF, I can just define it on the fly here and then apply that to my column here, mean max temperature. Now, .apply, we can also specify arguments for our function. For example, here our function takes a parameter called 2, which specifies what is the units I want to have. And here we convert temperature. We want to apply it to this column over here, and I want to pass this argument to that function. And apply takes care of that for you. So converts everything to absolute temperature and passes those arguments to the function that you have. Okay, now what if I have a function that doesn't know how to work with vector values, with series? I can use .applyMap. So for example, int as a function converts a number into integers, and float does the same thing with a number but converts it to float. However, if you apply float to a list of values, you'll get an error because it doesn't know how to work with a list of numbers. So in that situation, I can do apply map and then provide the function name, and it applies that function in an element-wise fashion on every element that exists inside of that data frame. And it's a pretty slow operation because it works element-wise, it's not vectorized. And usually note that for most of these operations, we have a vectorized version of that if we look carefully into the documentation. For example, if we want to convert everything to integers, we don't have to do apply map, which takes a long, long time. And here I have a test for you for this very, very small data set that shows you that in this even very simple case, it's still as type to convert the types is still 2 times faster than apply map. And as type is a vectorized operation versus apply map, which is not. Okay. All right. Now, next thing. Let's see how we can do grouping operations on data frames. Let's go back to our movie database that we had. And now, suppose that we want to group the rows based on the movie genre. Okay, so we want to look at the rows and bundle all of the rows with the genre drama together, and also bundle all of the rows with this crime, comma, drama together, and so on and so forth. And this is for doing some kind of operation on groups of rows. For example, I want to apply like an averaging function or a sum function to all the movies that have the genre drama, and then the same function to all the movies that have the genre crime, and so on. So we can do this by using this group by method. Again, this is something that we will learn much more about in our database course, but here, let's just take a look. So group by, and here we supply the column by which we want to group the rows together. Okay, you can see that it just returns a group by object. It doesn't return anything to you, just the object which provides you the functionality to do this group by. What a group by does is just a collection of key value pairs. So for each unique value inside of the column genre, it stores the indexes of the rows that store this value. Okay? It means that these rows have this value in their genre column. And then these rows with these indexes have this action, adventure, comedy in their genre column. And now this provides a way for us to apply functions onto those groups of rows. We can also return each particular group by using .getGroup, but this is not usually a very common operation. What we typically want to do is to apply some certain aggregation function, meaning that we apply a function onto groups of rows. Suppose that here I want to do the group by genre and then apply the mean. Okay, you can see that it computes the mean for all of the columns and for groups of rows with different genre. So here, the result of applying mean on all of the rows with this particular genre is this value for released year, and this value for IMDb. So on average, movies in this genre have received this rating, 8.1. And then in this particular genre, on average, they have received a rating 7.6. So you can see how helpful this can be for doing analysis on our data frame. Okay, as you can see, Pandas is complaining here, and this is because it wants us to look at our data frame and only pass those columns that contain numeric values into the mean function. So basically, it says don't pass columns to me to process that don't contain numeric values. So one thing that you could do is that using df.lock, first index into the data frame and separate the columns that you want, and then do the group by and do that mean. And this time, it doesn't complain. And don't forget to also include the column that you want to do the group by on in your indexing. Just some cherry on top, we can also apply multiple aggregation functions all in one go. This is again not something that is really necessary to know, but this is a nice feature. You can not only apply mean, but also the sum and count all in one go onto your grouped rows. Okay, and what I have done here is just for readability, I moved every one of these methods on a separate line, and I have done this by putting everything inside of this open and close parentheses over here. If I don't do that, I will get a syntax error. Okay, we can also apply different functions to different columns, and we do that by using a dictionary. So for this metascore column, apply max, mean, and this custom function. And for the column grows, just apply sum. This is, again, just something about the syntax that you might want to know. And you can do all of that in just one go. All right. You can also do aggregation for non-group data frames too, and which is not something that usually people do, but again, this is something possible. You can just skip the step in which you group the rows. You just do the aggregation on all of the rows, basically. Okay, any questions about aggregation and group by? Right. Was this again something that you've covered in 523? Okay, there's a lot of overlap then. All right. Now, one thing that comes up a lot when you're trying to clean up data is to deal with unknown values. So NANs that you see a lot in the tables that you load inside of pandas. So usually we don't want to leave it like that. We may want to fill those NANs with zeros or with some other values that are appropriate for our application. Before that, we want to see which columns, which rows contain NAN values. So if I do df.isNA, it just returns the data frame to me, but fills it with Boolean values, and wherever I see a true value, it means that there I find an NAN value, an unknown value. Here you can see a lot of trues here. And then for other places where we don't have them, we see false. You can also use the .info that we've learned about to see how many unknown values we have in each column. So here, out of 1,000 rows, this is the number of non-null rows. Now, this can help in seeing what's going on in your table. Okay, the function isNull basically does exactly the same thing as isNA, so you can use them interchangeably. What I wanted to show you is .any, which is very helpful to show you whether any of the values along a particular axis is null or not, is unknown or not. So here, for example, I asked pandas, hey, along the column axis, so for each row basically, do you see any unknown values? So for the first row, it says no, meaning that all of the columns have values. However, here for row 995, it says true, meaning that some or just maybe only one column contains null values. Okay, so any asks the question, is there any unknown value along this particular dimension or this particular axis? And we can use that to create a mask. So here, df is null, any axis that returns a Boolean series. We can supply that to our data frame and basically find where those NAN values happen. So, okay, there we go. We can see that those NANs, those unknowns, happen to be in the here in the gross column here. Okay, and here, for example, we also see them here. So this creates a nice way, provides a nice way for us to create a mask and then extract those rows or columns that contain unknown values. All right, there's another method called drop_NA, which basically drops any row or any column that contains an unknown value. So here we had 1,000 rows, and see that. Now we have removed any column that contains a null value, any row that contains a null value, and we are left with 714 rows in total. Okay, and then there is also this option to fill these NAN values with custom values. So fill NA, for example, in this data frame, we want to fill everything with zeros, the unknown values, and it does exactly that for us. So all of those NANs are filled with zeros. We can also fill them with the mean value of the data frame. And here I'm doing that with only with the column mean. Okay, and we have backward filling, which uses the value before the value that I'm encountering, and forward filling uses the value that's coming next after that one. And yeah, so again, if we have NAN values, it might make sense sometimes to fill it with any value that comes before that, any value that comes after that, with the average values of the table, things like that. So we basically do some sort of interpolation between the values. So this is about it for unknown values. Here is just a simple example to show you what we can do to actually visualize the data frames that we have to get a feel for what kind of values we have in our data frame. So for example, here, I'm visualizing the null values inside of my data frame using this package called Seaborn. You'll be introduced to these visualization packages in the next courses, but you can see that this option is also available to basically create a visualization that shows you where specific values exist. For example, in this data frame, we can see that the null values happen to be in these yellow areas. All right. So with that, let's end this lecture. Thank you so much for attending.